Okay, welcome back, everybody. We have a new topic today, and it's proving that a quadrilateral is a parallelogram. We have 5 new theorems today. We're going to prove them all, and 2 examples. So let's get started. By the way, notice as we go through these 5 theorems that they all end with the same conclusion, which is then the quadrilateral is a parallelogram. So we're trying to prove that a quadrilateral is a parallelogram, and we got 5 theorems to help us. Okay, our first theorem is that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So you can see here I have marked off the top and bottom sides of the quadrilateral to be congruent with the marks, and then I also got them marked to be parallel. And so we're going to prove that these 2 triangles are congruent. You're going to see we're trying to prove that, of course, we have a parallelogram for JKLM. This is what we're trying to prove here. So I'm going to say that JL is congruent to itself by reflexive property. And if you notice the figure, you're going to see that angle 1 is congruent to angle 2. Because if 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. So once you've established that, if you look at the 2 triangles, they are congruent by side angle side. Right, side angle side. And then once you notice that, then you have angle 3 and angle 4 congruent by CP-CTC. Corresponding parts of congruent triangles are congruent. So once you know that angles 3 and 4 are congruent, then you know because you got this letter Z. Remember we talked about a letter Z. You got alternate interior angles that are congruent there inside that letter Z. So that makes the left side, KJ, parallel to the right side, LN. And so now you have a parallelogram. Top and bottom sides were given to be parallel. Left and right sides were proven to be parallel. So that makes that a parallelogram. Okay, new theorem. This one says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we're trying to prove that figure ABCD is a parallelogram. Notice we got the top and bottom sides marked off to be congruent. That's part of your given. Also, the left and right sides are congruent. That's part of your given. So we also know that side AC, or segment AC, is congruent to itself by reflexive property. So that tells you that you have the 2 triangles congruent here by side, side, side. And then you're going to see right away, hopefully, that angle 2 and angle 3 are congruent. Again, by CP-CTC, corresponding parts of congruent triangles are congruent. And that's going to make the top and bottom sides parallel. It's going to make BC and AD parallel. Because, again, you got 2 lines cut by transversal. Alternate interior angles are congruent. That means those lines are parallel. Likewise, because of the congruent triangles, you have angle 1 congruent to angle 4 by the same reason. Corresponding parts of congruent triangles are congruent. And now you know because you have a different set of lines cut by a transversal, you have a different pair of alternate interior angles. That tells you that these 2 lines are parallel. So now we got the top and bottom sides parallel. We got the left and right sides parallel because of the alternate interior angles there. In case you didn't see that, here's the Z to make the left and right sides parallel. And then to get the other Z in there, this makes the top and bottom sides parallel. So 2 pairs of sides parallel, that's a parallelogram. Third way to prove 2 triangles, third way to prove that a quadrilateral is a parallelogram. We're trying to prove that ABCD is a parallelogram. The theorem says if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. This one's a little bit trickier to follow. So again, we're trying to prove that in this quadrilateral, you got 2 pairs of opposite angles. A and C are opposite angles, they're congruent. B and D are opposite angles, they're congruent. So we're trying to say that that's enough to say that this figure is a parallelogram. Okay, so we got a little bit of algebra to show you on that. So we know that the four angles, A plus B plus C plus D, add up to 360 because it's a quadrilateral. And so we also know that angles A and C right here are congruent. And so I can take these two, A and C, and just say 2 times the measure of angle A, because angle A and angle C are really the same. So I wrap those two into 2 times the measure of angle A, this statement right here. And then since angles B and D are congruent, you can see from the diagram, that means these two right here can be wrapped into one term here, 2 times the measure of angle B. Because angle B plus angle D would be the same as 2 times the measure of angle B, since B and D are congruent or equal. So I wrap those two terms into one right here. Okay, so if you go down to the third step there, then if you divide every term of this equation by 2, so there's 3 terms left, each term gets divided by 2, you get angle A plus angle B is equal to 180. And if you look at angle A and B, since they're 180, that means that the top and bottom sides are parallel, because we have a theorem for that. If 2 lines are cut by transversal and same side interior angles are supplementary, then the lines are parallel. So there's your top and bottom sides parallel because angles A and B were supplementary. Okay, so now we got these 2 sides parallel. But it's not a parallelogram yet. We got to prove the left and right sides parallel, but the process is the same. Again, start out with the equation angle A plus angle B plus angle C plus angle D is 360. That's just the angles of a quadrilateral add up to 360. And we got the same situation here. So these two together, angles A and C, since A and C are congruent, we'll just wrap those 2 terms into one here and say 2 times the measure of angle A, because angle A plus angle C is equal to 2 times the measure of angle A. Likewise, angle B and D are congruent, so we're going to wrap these 2 together into one statement. But this time we're going to call it 2 times the measure of angle D instead of 2 times the measure of angle B. Angle B plus angle D, they're the same, so that's the same as saying that 2 times the measure of angle D. So then you get that second line of your equation. And then to get this third statement right here, you're dividing every term by 2 again, just like in the previous example. So now we have angle A plus angle D is equal to 180. So if we go back and look at our diagram, we're saying that angles A and D are supplementary. A and D are supplementary. So that means that this time the left and right sides are parallel, and AD is a transversal, and A and D are supplementary, so that makes the left and right sides parallel. Because if 2 lines are cut by transversal and same side interior angles are supplementary, then the lines are parallel. So that makes these 2 sides parallel. And now I got the top and bottom sides parallel, left and right sides parallel. That makes it a parallelogram. Okay, we got 2 more to go. The fourth theorem says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. That should be pretty straightforward. So angle A, you can see there, which is x degrees, is supplementary to both of its consecutive angles. So angle A is supplementary to angle B, and angle A is supplementary with angle D. The fact that angle A is supplementary with B makes these 2 lines parallel, right? Because there's your 2 lines cut by transversal, same side interior angles are supplementary, so that makes the top and bottom sides parallel. So I'll mark that off. Those are parallel now. Now also notice that angle A and D are supplementary. One's x, the other's 180 minus x. So here's the 2 lines cut by transversal. And the angles A and D this time are same side interior angles, which are supplementary. We have an old theorem for that. If 2 lines are cut by transversal and same side interior angles are supplementary, then the lines are parallel. So that's going to tell you that the left and right sides are parallel. So I'll mark that off. Top and bottom sides are parallel, left and right sides are parallel. That makes that a parallelogram. Okay, our last theorem before we work a couple examples. Again, it's the same as the other four in that it ends with then the quadrilateral is a parallelogram. This theorem says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So you can see that, because I got it marked off, that the two diagonals, so AC gets bisected. You can see that by the two tick marks there. And also BD got bisected. You can see that by the two double tick marks there. Okay, so we got that. Now we have vertical angles here are congruent. Oldie but goodie, vertical angles are congruent. Now notice the top and bottom triangles are congruent by side angle side. Here's what I'm talking about. So this triangle is congruent to this one. They're congruent by side angle side. Okay, so what that tells you, since corresponding parts of congruent triangles are congruent, it tells you that angles 1 and 2 here are congruent. By CP/CTC, corresponding parts of congruent triangles are congruent. Angles 1 and 2 would be the overlapping triangles if those two triangles were put on top of each other. Not only that, we know that okay, but before we move on to that, so because angles 1 and 2 are parallel, now we know that the top and bottom sides are parallel. Because we got that old theorem, if two lines are cut by transversal and alternate interior angles are congruent, then the lines are parallel. Okay, so we got angles 1 and 2 parallel, angles 1 and 2 congruent, making the top and bottom sides parallel. And the top and bottom sides are also congruent because of the same reason, CP/CTC. So we can say this top side and this top side are congruent by corresponding parts of congruent triangles are congruent. And so the reason why then ABCD is a parallelogram is because you got one, it's our first theorem today. We're using the first theorem of today to prove the last one. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So that first theorem helps us prove the last theorem here. So now we know that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, let's look at our two examples, and then we'll wrap it up here. Okay, so the directions say show that quadrilateral ABC is a parallelogram if x is equal to 7 and y is equal to 4. So we're going to plug 7 in, and we're going to get the lengths of the sides of the top and bottom. So we've got the top is 7 plus 14. That's equal to 21. So we know that the top of that quadrilateral is 21. Now you're going to put that 7 in for the bottom side. So 3 times 7, that's 21. So we know that we got one pair of opposite sides to be congruent. Now let's plug in 4 for y for the left side. So we got 5 times 4 minus 4. So that's 20 minus 4, that's 16. So the left side is 16. And then we'll do the same thing for the right side. So we got 2 plus our 4 plus 8. So 8 plus 8 is equal to the 16. Okay, so how does that prove that that's a parallelogram? Well, we got a theorem for that. That theorem was one we just proved. If both pairs of opposite sides of a quadrilateral are congruent, which they are here, then the quadrilateral is a parallelogram. Okay, one more example here. Show that quadrilateral EFGH is a parallelogram if Z is equal to 11 and W is equal to 4.5. So it looks like we have three angles there to calculate. So we got 11, I'll do angle H first. So we got 11 times Z, which is which is 11, minus 3. So it's 121 minus 3, so that's going to be 118 degrees. So this angle is 118 degrees. Let's find angle G next. So that's 14 times W, which is 4.5, minus 1. So calculator, 14 times 4.5 minus 1, that's 62. So this angle right here is 62 degrees. And let's find angle F. So we got 9 times Z, which is 11, plus 19. So we have 99 plus 19. That's going to be 118. So that angle is 118 degrees. So how does all that prove that we have a parallelogram? Well, as usual, we have a theorem for that. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. So angle G is supplementary with H, right? They add up to 180. Angle G is supplementary with F. They add up to 180. So you got an angle in a quadrilateral that is supplementary with both of its consecutive angles, so that makes you have a parallelogram. Okay, let's wrap it up here and review these theorems. There's 5 of them, but they all, like we said, they end the same way. The first one was if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. The second theorem we had today was if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Then we had if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Then we had the one we just used here. If an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. And finally, the last one we did today was if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Okay, you've got a couple assignments then, and let's go ahead and get some practice with our new theorems. Good luck.